find the principal unit normal vector. So if we consider this problem, we have to first find r prime of t. This is I plus 2 times a half times t, so this is just t j. We find its norm is the square root of 1 plus t squared. So the tangent vector is r prime of t divided by the norm of r prime of t. So this is 1 over the square root of 1 plus t squared I plus t all over the square root of 1 plus t squared j. So to find its derivative, we rewrite this tangent vector, in particular for that first term. I'm going to just write this as 1 plus t squared to the negative 1/2 times I plus t all over the square root of 1 plus t squared j. Now we find its derivative, so t prime of t, there's a lot of work there, so that becomes just the power rule, negative 1/2 times 1 plus t squared to the negative 1/2 minus 1, negative 3/2 times the derivative of the inside, 2t I. Move to the next term. So it's the product, well here the quotient rule, so the derivative of the top is 1 times the bottom is the square root of 1 plus t squared minus the numerator times the derivative of the denominator, so that's going to be 1/2 times 1 plus t squared and that's 1/2 minus 1, so this is negative 1/2 times the derivative of the inside, 2t, all over our denominator squared, so that just gives us 1 plus t squared, and this is all times j. We simplify this, so t prime of t is equal to the negative 1/2 times 2t is just negative t, and that's all over 1 plus t squared to the 3/2 power I. And then we clean up the jth component, so just leave that 1 plus t squared there, minus, we'll fix up this side over here, so 1/2 times 2 is 1, t times t is t squared, is negative t squared, and the negative exponent, we just drop it downstairs, the square root of 1 plus t squared, and that's all over 1 plus t squared j. So just one more cleansing. So this is negative t all over 1 plus t squared to the negative, or to the positive 3/2, excuse me, times I. I'm going to fix this side here. I'm going to add these two fractions, and so to do that we have to get the same denominator. You know, these denominators here will be 1, the square root. So I'm going to multiply to this radical the square root of 1 plus t squared. And then also we're going to multiply it downstairs to that 1. When you do that, you get the square root times itself, so we get 1 plus t squared minus t squared. And that's going to be all over the square root of 1 plus t squared times 1 plus t squared, which is 1 plus t squared to the 3/2 power. This times j. So see if I can put it here. Probably not the way I write, but I'll try it. So this is negative t all over 1 plus t squared, the 3/2 power I. The t squares there cancel out, so this is just plus 1 all over 1 plus t squared, the 3/2 power j. And this, let me go back up for my sake. The question was find the normal vector. So good. So to get the normal vector, you know that guy is defined as being t prime divided by its norm. So we have to find the norm of t prime. So the norm here of t prime of t, it's going to be the square root of negative t squared, and within the radical plus 1 squared, divided by, now the square root, these two denominators are the same, so it's going to be the square root of that denominator squared, so that just comes out of the radical, and it stays the same. So the numerator, you have this negative t squared plus the 1 squared, and this is all divided by this denominator, because once it's squared and then you take the square root of it, then we just get the same thing. So this is 1 plus t squared, the 3/2 power. And you simplify this, you have the square root of, I'm just going to write the 1 first, plus t squared all over 1 plus t squared to the 3/2 power. That's the same thing as saying the square root and then times that term again. So just break this down. So this is I did that so you can see that the radicals canceled, and all we have left is 1 over 1 plus t squared, and that's for the norm of t prime. Well, we need that to find the normal vector. So the normal vector n of t is equal to t prime of t all over the norm of t prime of t. So t prime we have there, let's divide it by this 1 over 1 plus t squared. So t prime is negative t all over 1 plus t squared to the 3/2 power, and that's going to be divided by 1 over 1 plus t squared, I plus 1 over 1 plus t squared to the 3/2 and divided by that norm 1 over 1 plus t squared j. So the normal vector, we clean that up. This 1 plus t squared goes up top to the numerator, divided by 1 plus t squared to the 3/2 power. So all we have left is a negative t, and the 1 plus t squared goes up in the numerator, and downstairs is 1 plus t squared times the square root of 1 plus t squared. So all we have left is the square root of 1 plus t squared I plus, this is just 1 over the square root of 1 plus t squared j. And I believe they gave us a number to evaluate little t. So we evaluate little t at t equal to 2. There it is. So n of 2 is equal to negative 2 over the square root of 5 I plus 1 over the square root of 5 j. Now I want to give you a note here. Maybe it's a remark. If t of t, say for example, is equal to x of ti plus y of tj, then there's two possibilities for the normal vector. Since the tangent and the normal vectors are perpendicular, then we say then either n of t is equal to negative y of ti plus x of tj, or n of t, yes, is equal to y of ti minus x of tj. Because the tangent and the normal are perpendicular. So if you take the dot product of these two vectors, then you want to get 0. Now how do you know the sign? And that's a good question. The tangent vector will always flow in the direction of how the curve is moving. So say for example, if we take this problem here, and I'm looking at this position vector, this means that x is equal to t, that first component, and then y is equal to 1/2 t squared. So if x is equal to t, that means that y is equal to 1/2 x squared. So what we have is just a parabola. Reduce everything to x and y. So we have a parabola. If you care to study the direction of this, you'll find that the direction is moving this way. And you take also the value of t. You start with t, so if t is 0, x is 0, and y is 0. If t is equal to 1, then x is equal to 1, and y is equal to 1/2. If t is equal to 2, x is equal to 2, and then y is equal to 4 divided by 2, we get 2. So if we're there, and then we go x is 1 to 1/2, and then x is 2 to 2, we're doing that, and so we're moving in this direction. So if that be the case, and then if you evaluate at t equal to 2, well, if t is 2, that means that x is 2 and y is 2. So we're here. So since the curve is moving in this direction, that means that the tangent at that point is doing that. Maybe I can draw it a little bit away so you can see it a little bit better. Now this drawing is, it's not good. Okay. But you get the point. So if the tangent is doing that, that means that the so-called normal vector is going to run in the direction of the curvature. Well, the curvature is doing this. So that means that the normal vector is doing that. You see that? Now, watch this. From the direction of this tangent vector, x is moving positive. It's going to the right. And then y is moving positive, right? It's going up north. Now, watch the normal vector to get the sign in terms of, if you don't want to go through all these steps in terms of trying to find the normal vector. If you got the tangent vector, you can get it. Now look at this. For the norm, this is the tangent. This is the normal vector. The normal vector, this direction for the x values, well, x is negative going in this direction, right? So x is negative, y is positive going up. So the normal vector, the first component for the normal vector is going to be negative, and then the second component, the y component, is going to be positive. Now, come down here and look, and then you just flip the x and y from the tangent vector and you get it. So this is the normal vector. Where's the tangent? That tangent is here. There it is. That's the tangent vector. The denominators are the same, right? Look at the numerator. This is 1, this is t, right? Now watch, for the normal vector, it's going to flip-flop. So it's going to have a t here and a 1, and then this sign is going to be negative. Because for the normal vector, look, x is moving in the negative direction, going left. See that? Negative t and 1 there, the same denominator. So that's one way you can do it without having to go through all this work trying to find the normal vector. Who likes to do that? I don't either. Okay, let's look at another one. This is an easy one. I like this guy. Excuse me. So here we're going to do the same thing. Find the principal unit normal vector. We got to find r prime of t. So this is -6 sine t I plus, taking just the derivative, this is 6 cosine t j. And this component here is 1, so the derivative of 1 is 0. So we're done there. We find r prime of t. If you see it, you know, this, since this is sine and cosine, you square them, and the terms in for their coefficients, basically their magnitudes are the same. The magnitude is the same. So you square those, you get 36. You factor it out, take the square root, you get 6. So the norm is going to equal to 6. So hopefully you see that next time you just do it, right? So this is -6 squared, 36 sine squared t, plus 6 squared is 36 cosine squared t. You factor out 36, so you get the square root of 36, you get 6, and the square root of sine squared plus cosine squared is 1, right? So the tangent is r prime divided by its norm, so we just divide everything here by 6, so this is negative sine ti plus cosine tj. Take r prime of t. This gives us negative cosine ti minus sine tj. Its norm, the norm of t prime of t, that's just 1, right? So here, n of t is equal to, dividing by 1, we get the same thing as t prime. So this is just negative cosine ti minus sine tj. And then they wanted you to calculate this normal vector at t equal to 3 power over 4. So n of 3 pi over 4. So it's equal to negative cosine of 3 pi over 4 minus sine of 3 pi over 4 j. Well, cosine power of 4 is 1 over the square root of 2, and 3 pi over 4 is just 3 times 45. That puts you in the second quadrant. So in the second quadrant, the x value for the unit circle would be negative. So this is negative times this negative sign there, so we get positive 1 over the square root of 2i. And in the second quadrant, sine is positive, so this will be just negative times positive is negative 1 over the square root of 2j. And that's it. Next, we'll come back and we'll work 2 problems finding the tangential component of acceleration and also the normal component of acceleration. Thank you.